Okay, then we are good to go. So, before we continue to the volumetric analysis, because I'm aware that we are supposed to be starting from there, the volumetric analysis, I thought maybe can just go through some of the questions. Of course, I know you're given some of the assignments to try. I was not around for the 2 days. I think Wednesday and Saturday. I was prepared for something, uh, which I am done with. So I just want us to write some maybe. We can just remind ourselves because I know that you did some of writing of equations. You taught even the steps of writing equations, chemical equations. So I think we can only do maybe we can do let us do maybe three, and then we just proceed to uh, volumetric analysis. So I'm using the long one for questions. Like I said previously, long one has a lot of questions. Um, the KLB, on the other hand, is very good for teaching. But if you want to do more practice, you can use the other made familiar and the rest. But the KLB is very good. If you have the KLB again, you still can work it out. So let us do question number one. Oh, let us do question number two. I think one is very easy. Let us do question number two. We can even do the all of them. I don't know how many we are. Everybody can do there so that it becomes very easy. And these ones, write the balance equations for the following reaction. So it's just balancing equations. This one is very easy. So I'll give Maura the first one. I don't know the way it appears from the screen. Uh, let me check. Let me check. I don't know. Let me minimize. I don't know who comes first. I think I've seen Maura. I've seen Monica. Who else have I seen? I think I've seen almost three people. So let us just write. You write A. That is, you can do that A, then B, and then we go now to the titration directly, which I will use another. Is that okay? I don't know if that is okay. Just yani tujikumbushe tu because we are going to use them hapo chini. We are using the same. Most of these equations, if you don't know how to write the equation, it will be a problem on the other side. When you are where we are going now, where is the titration? Which we have three titrations. Which I'll just skip some of the parts and then we just go directly to something. So let us write only A, B, and C. Uh, yeah, let us write the whole of two. I'll do one also. So you can, kila mtu choose yake and then you tell me which I can do. And I'll just do the three. Neutralization of sodium hydroxide with the dilute sulfuric acid, burning methane in plentiful supply of air, and then reducing iron 3 oxide with carbon 2 to produce iron metal and carbon 4 oxide, burning hydrogen and oxygen. These are very easy. Very easy. So let me do question B. I'll do 2B. I'm seeing that it is kind of, so let me just do mine immediately. But you can try, you can continue doing. The only reason I brought this one out is because I want to tell you something, which I know most probably maybe you have forgotten, because I know you're very busy. So they've given you the formula for methane, which is okay. So it is CH4. Now remember the rules of writing these things. When what you are told in form this one is a gas. So what you're told in form 2 ni ukiandika, make sure that the C and the H are the same size na zizikutani. I mean, they should not touch each other. So don't forget that one. In plentiful of air, that is plus oxygen. Now, when they say plentiful of air, we have another. That means in limited air, amount of air. So venye mulifunzwa, when they were teaching you about how to write the chemical equations, I think what we are told here is what you call the stoichiometric equations. So mkiandika those equations, you must indicate the state. That is why nimeweka gas because they have given us. So it will produce CO2. Don't mind this one because I'm using the cursor, which is kind of not making sense to me, plus water. So in the steps that you're told you must know the products, the reactants of the products. You must know the chemical. That is why the other time I was telling you it is very important for you to know the chemical formulas of the atoms that are reacting, or the individual atom that is making up that particular compound. So for example, here methane mulipewa. Oxygen hatukupewa, but you are supposed to know that it exists as a molecule. Carbon dioxide hatukupewa, but they gave us the name. That is so you're supposed to know the reactants, which is E na plentiful supply of air, which utilizes the most active part of air, which is oxygen. That is why nimereact na oxygen. Now, ukishafika hapo, just do you balance now. So if I place I don't know if I put a 2 here, you check, make sure that it is okay. So if I put a 2 here, it has already balanced the hydrogen. But the oxygen is now, this one is 4. So I just put 2 here. So the carbon remains. So this one is balanced. But it is, you must show the state symbol. So this is liquid or gas, depending on the temperatures, which most probably itakuwa gas because of the temperatures that are produced when you're reacting methane. And then you have the gas, and then you have another gas. So you must show the state symbols. So you must not forget the 5 processes. I don't know, the 5 steps. I think it is almost 5. Knowing the reactions and the products, knowing the atomic numbers, the atomic names, symbols, and then now you write, and then you balance on both sides the number of atoms on the products and the reactant side. So in my case, reactant, product. Because maybe do I have to do something else? I can just go to something else there. We can go to titration directly because we're already late by almost a quarter of an hour. So iko sawa. I am very sure that you can remember these ones. But it is very important for you to know how to write the equations and balance. Unajua kuandika is not a problem. I even found out that students know how to write the equation. Balancing is where they draw the line now. Mtu atasema sijui, they have a lot of explanations maneno ya balancing. So it is very important for us to know how to balance. I hope everybody is okay so that I want to use another book, but we'll come back to this one. I don't know. Can I give you these ones as your assignment? I can even take a picture and send them as your revision exercise. But I sent this book to the group, so it is still the same. It is still the same book. So you can just go and check on it. So we have a lot of them. That is why I wanted to, you see, it has a lot of questions. Yeah, and then I knew you were told about ionic equations, so which is okay. Precipitation reactions. Now, when you talk about precipitation reaction, there's something I want to touch on when you talk about ionic equation, which we already did, and it is where wapi sasa hii? Yes, this one. Yes. So when we talk about precipitation reaction, that is ionic equations, especially when you're talking about the source now. Solid. I don't have a problem with the gas because most of you know which the gases that exist. But we have a problem knowing the source that do not dissolve. So we have the lead, chloride, silver chloride, for chloride, sulfate. So it is very important for you to remember those ones. But that one was not mine. I just remind you that you should know all those things that are insoluble so that when you're writing ionic equation, those ones that precipitate or those ones that form solid, gases, and liquids are not cancelled out as protected ions. Ni hiyo tu nilikuwa na. So all carbonates actually are insoluble except the group 1 and ammonium. So that one is very important. I just wanted to mention those ones. Insoluble again, when it comes to hydroxide, you should know that all hydroxides are slightly soluble, which basically means they might not fall under the category of spectator ion. I think that is all I wanted to share about with you now. But let us now go to the original. tuko sawa, Maura? I don't know if people can hear what I'm saying. So sometimes I find that maybe
Yes.
unajua labda naongea vitu zangu tena but since it has been long since we met, so I know if this one is the correct one I want to use. Let me just confirm it. Yeah, I think now this one. So this one now is the KLB, but we'll go back to the other one. We'll go back to the other one. So you did all of those ones, solution. Hizi zote mumefanya. I just wanted us to remind ourselves before. So stoichiometric equation, where we say it is all number ratios. That one, ionic equation, we have speculative ions possibilities. There are three possibilities actually during ionic changes: precipitation, formation of a gas, and a liquid. So those ones. But it is very important for you to remember those ones. That's why I had to touch on them. Because where we are headed, it goes a bit. So it is very important. So volumetric analysis. Volumetric analysis. Now, this one is actually, when we were in high school, what we were told about volumetric analysis, we were told kuna topic inaitwa moles. They never actually told us it is moles. The first part is easy. Walisema kuna topic inaitwa moles. Kumbe moles zenye walikuwa wanatuambia ni ngumu ni hii sasa, ni yenye tuko saa hii, this one that we are in now. Now, so volumetric analysis. Now, I know you are preparing for your, somebody's mic is on, Now, I know you are preparing for a practical. I don't know if I'll be around, but I had already given out suggestions of what we're going they're going to set. Of course, one of the practical sessions you must have, ile lazima mupate, is the volumetric analysis. It can be either of the ones that we are going to mention, which I have talked about only three. We have the direct titration, we have the back, and the redox. Now we'll explain the difference, of course, but the simplest one, which is the direct, is the one that we are going to handle today. We'll handle more than one so that people can understand. Now, so when you talk, so I'm saying the practicals that we're going to do today, not today. Now that is the problem of teaching online, because now I would have taught this one and taught actually how to perform one practical, which ningewaonyesha. Yeah, I would have demonstrated. We normally say demonstrated, not really a dry one, but we do a practical. Yenye wanaona, I do one, they do maybe as the students. But there's no problem. The most important thing is to understand how to handle these things. So it is a method of quantitative chemical analysis. Now, there are two things that you're supposed to know. There's some, I think I'll share before you go for, I don't know when you're doing your practicals. I don't know, they said it is the weekend, which weekend? This weekend, this coming weekend, I'm not very sure. I don't know who is very sure about when you're going to do practical so that I can know what to do.
Teacher told us, Madam Martha.
Yes.
Told us that we shall do it on the last week of April.
Okay. So it is yet to. Okay, then there is no problem. But there's something I wanted to share about the practicals, but I'll still share it. I think I'll still get some time, since I don't think I'll be very busy since they're starting an exam. I think this week, so I don't think we'll be very busy. So nitakuwa around. I'll request maybe on Saturday we do something. There's something I want to teach about the practical. So we might not really continue with the syllabus. But for today, I wanted to only introduce this so that nikifunza hiyo the other thing of practical, please, it will be making sense. Now, so we have two types of practicals. Now, number one mostly is the quantitative analysis, which actually you are doing quantity. Quantity is number values. We are talking about numbers or certain values. So that one is quantitative. That is volumetric analysis. Now, when we talk about another one now, which is normally maybe question 2 and number 3, is what you call test for cations, test for ions, test for anything else. is what you call qualitative analysis. Qualitative, you are testing the quality of the ions that are present, or you are testing the quality of that source. Now, so quantitative analysis normally takes parts, maybe 20 marks. The qualitative will take up the other 20. So it is very important to know, but it is very easy to score all the quantitative, which is the one we are dealing with, than the qualitative, because it is number of, we are talking about values. So you are only you have to follow some rules when you are filling maybe the table or when you're doing the titration, which we will talk about that one. So it is a quantitative chemical analysis to determine. We are determining by measuring the volumes of solution. So we mostly will be using two solutions, but I'll not explain using this one. I'm not explaining that one. I just wanted to now, after you're given two, I will use the long one when I'll be explaining in the question. We'll use an example so that people can understand better. Now, you are given two solutions, and then of course you determine the concentration of one, knowing the concentration of another one. So we just have to do, and that process now is what we call the titration. Now, we have a solution which exact concentration is known. That is what I said, and that one is called the standard solution. Now, I love the apparatus that we use are those ones that are used to measure accurate volume. Remember, tukianza hii topic, I don't know if it is this one or another one. There is a place I mentioned being asked apparatus used to measure accurate volumes and to measure volume. I was very specific that ukiamua kujibu hiyo swali, you either score very well by using the answers to measuring accurate volume are specific. Answers to measuring volume are all of them, including the pipette, burette, syringe, and the volumetric flask. Lakini it is very important, nilisema wakiuliza accurate volume, andika hizo zenye nimesema: pipette, burette na syringe na volumetric flask. Wakiuliza measuring volume, yani bila the accuracy part, ni hizo bado. If you name them, so you'll be on a safer side, so that if you're moving very fast or you are rushing to complete the exam, haitakuwa affect. Now, of course, the pipette is normally designed to deliver definite. When you say definite volume, is actually a volume that is known. And let me just say this for the sake of us, yenye tunatumia ni ya 25 centimeters cube. Now, as we continue, there is some things I normally mention. 1 centimeters cube, so that mtu ukiwa huko, I know when you are there, when you're doing the practical, especially when you're doing in the KCSE, nobody will, unaweza pata imeandikwa 25 centimeters cube kwa swali, lakini unapewa what do you call the pipette, pipette yenye unapewa imeandikwa hivi, imeandikwa 25 mils au milliliters. So 1 centimeters cube is equal to 1 ml. So ukiambiwa hivi, it is the same thing. Don't be worried. Don't even raise up your hand. Don't ask anybody. We had mentioned that one previously. Sorry. So don't ask anybody. Tuko sawa mpaka hapo? That one. So how we do this one? Now, I like the long one procedure. The long one procedure is very nice. But before we go to that one, let us just go to this one. So when you're given, now, when you have a pipette, most of the times I don't advise students to use a pipette filler unless the chemical that you're given is poisonous. It can peel your skin. It can peel your. For example, when you're given sodium hydroxide, that is above 2 molar, or that is 2 molar, 1.5 molar, 1.25. Those ones they are corrosive. Sodium hydroxide is corrosive. If you drink by mistake, hata wash aje, it will still leave some, itafanya, what do you call, it will peel some of your skin from the lips, so your lips will turn very red. It will not kill you, it doesn't kill, but you will feel some pain, utasikia uchungu, which sasa, so that is when we use a pipette filler. The only problem with using a pipette filler is I cannot explain how to use a pipette filler because I have to show it literally. Venye unafinya alafu urudishe hewa polepole mpaka ifike. So I normally advise, now we have A, this one, and B. So the first person, A, is using a pipette filler. The second person is using their mouth to suck the liquid. So there is no problem. You can use either. Now, yes. So before rinse the so that it doesn't affect actually the molarity or the concentration. You rinse it with the solution that you're going to draw. Ipitie tu and then you fill this above the calibration mark. So the pipette inakuanga na mark fulani, iko na mark. So ukivuruta na mdomo unapitisha kidogo that mark, alafu shikilia na kidole, alafu fungulie hewa polepole, it will be dropping. Now, so ukishamaliza, ikishafika the meniscus, of course I hope you know how to read the meniscus. Of course you don't read the upper line, nasoma ya chini, yeah. So ikifika hapo, you transfer it to now what we call not the volumetric. It will depend on the question. Sometimes you can use the volumetric flask, but mostly you transfer it to the conical flask. Now, let me show you the conical flask. I know now, so that when you see it, this one una transfer kwa hii. Let me just circle it. Unaona kitu inakaa hivi. That one is the conical flask. Now, after transferring to the conical flask, because when we explain, it doesn't make sense. I know people get tired when you explain a practical session. Even me, I do get the same feeling. I do get the same feeling. So now, ukisha transfer it to this one. So pipette fillers must be used when that is what I was saying. What especially in sodium hydroxide, which is concentrated. But if it is 0.1 molar, hiyo ukikunywa, it doesn't have effect. Unakunywa tu maji, you just gargle water. Now, so you transfer that thing to the conical flask. Now, so we are done with using the burette. Ukishaweka, ukitransfer hapa, you are done using the burette actually. Unaweka the pipette, sorry, not the burette. You are done using the pipette and the pipette filler if you add one, and if you know how to use it. Now, I normally tell my students, kama haujui kutumia pipette filler na umepewa, usikaribie. You will waste a lot of time. The 2 hours will be like done before you ukiendelea kusaka. Now, using the pipette filler, because the pipette filler it needs very high precision, because you are pressing around how many sections? 1, 2, 3, 3 sections. So it needs a lot of precision when you're using it. So after you have transferred that one, now we go to the burette now. So let me just go back kidogo so that you see. I'll show you using the long one. Now, the burette is this one. Let me just show you the burette. Kuna kitu unafungia sasa kwa the clamp and the boss. Hii, kuna kitu inaanga. Naona kitu hii hapa. Let me just draw it so that there is something hanging here. Unafungia hapa. Now, ukifunga, I know now the people wenye wanawachunga time ya practical, they are very rude to you. Tafadhali, funga pole pole. Nataka I'm very happy that most of the students are women. So, I want you to imagine your kid breaking in your newly acquired glass. Umenunua glass ya Luminac, alafu mtoto akapasua siku hiyo. So you should do the same. I know they harass you, but I don't know if it's their job, but this thing is a little bit expensive. So unawachungia tu. So ukifunga unafunga polepole until haisongi tu. When it is not swinging, if it can hold then it is okay. Ishike tu vizuri. So that one is the burette. That one is the burette. And the burette is normally calibrated to favor the student. I don't know why students normally get confused. The burette is normally calibrated to favor you. It doesn't favor me. Now, let me tell you how the burette is normally calibrated. That is why I'm saying we are supposed to be doing it practically. But I'll just explain for the sake of situelewe tu, alafu tukishika mtakuwa mnakumbuka. I hope I'll be I hope I'll be around when we be doing it so that it becomes easy. So nitakuwa nasema siku ile tulikuwa tumesema hivi. I don't know. Let me just remove this one first. I don't like this one. Kidogo, so that it doesn't mess us up. I'm supposed to zoom and it is not working. Give me a few minutes. No, this one is the one that is. Let me stop sharing and then I share it again for the sake of that thing that is in a Nikinga Nisi. So a little bit. So I'm saying when you're using that thing, make sure ukiitumia unaichunga isi. Somebody is on. Somebody is on. Somebody is on. Sorry about that. Yes. Okay, yeah. Something was running. So when you're using that thing, make sure kama unaona inaenda kupasuka. I don't know. I want you to tell me, are the people who help you when you're doing it allowed to even touch your, can they help you? Wanawasaidia? Maura, you can tell me as I open this one. Are they allowed?
Mwalimu,
Yes?
unauliza what are allowed?
Are they allowed to help you?
Oh, the nearby schools.
No, I'm saying when you're doing the practical,
They are not.
yes.
They
So that
don't
is,
help.
yeah, so that is a problem. You see? So
Mhm.
that is an issue, that is an issue. So I don't know. Yeah, I wanted it to be clear this way. I was trying to make it larger, but this one is a book, so it was not making sense. So unaona sasa shida ni, that is the only problem that we have. So for example, when I'm, because most of the time I'm there during the practical, if my student ajui kufunga huwa namfungia. Yeah. So that is now another difference between now you and the other students. So you know shida. So I'm not sure anyway, but in short what I'm saying, lakini hata nyinyi glasi ikipasuliwa na mtoto wako hata wewe unakasirika. Now imagine mtoto wa jirani akuja apasue glass umeleta leo. That would be more painful than your kid, yeah? So what I'm saying is when kama mtoto wa jirani umeenda kupasua kwa mtu, so it becomes even worse. So but anyway, I'm very sorry about whatever happened. Ni hapa tu ushike ukue. You become very confident, not overconfident, just be confident. Yani watu waone like you know what you're doing. Yeah, which I know you would know. Now, I was also talking about now the burette, how it is normally calibrated. Now, this burette is normally calibrated such that pahali itasimamia solution, that is actually the correct reading. Now, this thing is normally 50 centimeters cube, or somebody else can say it is 50. So nasema ukiona imeandikwa 50 ml ama 50 centimeters cube, you don't mind. Remember, hii ni 25. yenye tunatumia. I'm saying this because this one is the standard one that we use in our system. Now, if you go to other places, they use even up to 10. But now for the form 4, we normally find that if you use 10, it will be the solution will be very small and you might not really get the value. But if you use 10, it will be more accurate than the 25. There's something about 10 and 25. You'll get the difference with more accuracy coming to the smaller volume. I hope that one. So this thing is normally calibrated from 0. Hapa juu ni 0. Hapa chini 50. So ukijaza mpaka hapa juu imejaa 50. Now as you continue running inakuja chini. So it be counting 0, 1, 2, 3. Hata kusema umetumia 25. So itafika 25. So ingekuwa 50 in a run ikikuja you are supposed to minus. So hii inakuambia directly the volume that you have used. You don't have to minus anything. Just count from there. Kama ni 16 inasimamia 16 and the answer is 16. Yeah. So I think that one, I don't know if you've realized that. So in a run from juu hapa ni 0. Hapa chini ni 50. Yes. I wanted to talk about that one. So ukisha transfer, so we are talking about now the burette, so which is okay. So it's normally interval, it is graduated from 0 to 50. That is to your advantage. There's a student who said ingekuwa huko juu ati ndio ujue imejaa 50. So ikifika kwa 0 unajua imejaa. That is what I'm saying. Now, of course, before using it again, you can rinse it with the solution that you're supposed to ipitie to, that is to maintain the concentration. Feel carefully, and then now we have now the titration process. Okay, so that one, the volumetric analysis nimesema is the titration process. We say analysis, volumetric analysis, we are doing quantitative. Now, for us to get those quantities, we have what we call the titration process. So umeshajaza your liquid kwa the burette na umesha pipette something to the conical flask. You add now what we call an indicator. Now, I normally tell students, when you have phenolphthalein as the indicator, uko sawa. Because it will be purple to colorless or colorless to purple, which is easy to know. Now, when you're given the methyl orange is normally a little bit complicated. So if you practice more on methyl orange, na ushike, phenolphthalein itakuwa nywe. To be very easy. So phenolphthalein, purple to, of course, we'll see that one. So so the solution that will be in the conical flask now. You add you add maybe the indicator. You add an indicator. The indicator will give you a color. Now, the indicator normally shows when the process has ended or when the reaction is complete. And that point is normally called the end point. Inaonyesha imefika mwisho. So you should stop running or you should close the burette. Burette inakuanga na tap, zingine zinakuanga na tube fulani za kufinya, so there is no problem. Now, the volume of the solution that runs from the burette, ile sasa nakwambia una run from 0 to 16 is called the titer. Na hiyo titer sasa unajaza kwa the table, which I'll show you. And then I'll teach you how to fill that table. So let us move a little bit. So the volume used, you will write. And then you can dispose that one. Now, most of the time, we normally give 2 conical flasks. Only 2. So you can dispose one, alafu you run this one 3 times. I'll tell you when we reach there. Let me just not talk about that one. Now, so you have the titration 1, titration 2, titration 3. Somebody asked me, why can't we just do 1? Now, we cannot do 1 because we are human beings and we are prone to making errors. Due to your errors, to eradicate errors, it has been found that when a person does something 3 times, the probability of reducing the error is 1. So that is why we do it. So ukisha final burette reading, in fact you are given the final burette reading and this table is to your advantage again. So the initial, mara mingi initial si ilikuwa pale ilikuwa imesimamia which ni huko juu, so unapata 0.0. So final for example is 16.3, unaandika 16.3. Now initial kama inatosha, kama unaona liquid imebaki inatosha run another process, you can continue. Lakini kama haitoshi, ongeza ijae irudi kwa 0 tena. For example, let me wrap this so that I can explain that. That is, for example, kama umepata hapa ni 30.2. Now I want you to see how venye mi naandika yangu. Now yenye imebaki kwa 50 ni ngapi? Si ijai 30 tena. So what you do, unajaza tena irudi 0. Now the initial for titration 2 will be 0.0. I'll give you the formula how we fill the rules we use to fill this one. Before then, before I even come there, before I come there, so you must do 3. Na nimesema kama burette, if the liquid that you have used is more than 25, unajaza tena. Kama inatosha, kama haitoshi, if the liquid is not enough, use what you have. So I know nyinyi mnakaziwa, if it is 100 they give you 100, if it is 150 they give you the actual 150. For example, mara mingi wakikupea 100 centimeters cube, that means it will be doing 30. So unapaswa kujaza jaza, that means your initial will be the same. So nyinyi mnachungwa sana. Anyway, now I want to do now acid, the color indicator now. Now the indicator, that is why I want you to see something about this thing that is not making sense. Yenye nilikuwa nawaambia sasa. Now phenolphthalein color in an acid solution is colorless, so ni kama maji. When it is in a alkali solution, that is in a base, it is normally, I don't know, it is not pink. Unless when it is not contaminated, it is pink. But most of yenye tunatumia is not actually pure. It's normally not pink, it is normally purple. So it is pink or purple depending, but it is okay. But I normally tell students it is purple. I know pink, I don't know. So that one is okay, it is normally purple. And then you see if it is purple to colorless, if it changes to colorless, that one is very easy to see purple changing to water. Yeah. Now we have methyl orange that we can be given. It has been long since they brought this one in the KCSE. I think it was maybe 3-4 years ago. They have been bringing phenolphthalein for quite some time. If they bring, the problem with this one is it is changing from yellow to orange. When you are given the acid equal pink to yellow, it is better. Lakini mara mingi ina change from yellow to orange. It could change from, I don't know, I'm a man. Most probably I'm colorblind. But the difference between yellow, ya lab, na orange, ya lab, I don't know if you have ever had those things. Which, by the way, talking of the practical, if I'll not be there in that practical, I'm suggesting that they give you a practical that has methyl orange. That you're using methyl orange as an indicator to show you the endpoint. So, now, most of the screen methyl orange is very expensive. This one is very expensive. Very expensive. I don't even think there is no place they will ask us to use screen methyl orange. Now, the phenolphthalein and the methyl orange, I don't know, it goes between 1,000 to 2,000. So that you know how expensive screen methyl orange is normally used in the lab. This is Cambry and the rest. It goes for the same amount, the same liters, of phenylephrine and methyl going for around 5,000 plus. So it is very expensive. That is why now we don't use it most of the time in schools. So we don't, but now you should know the colors. This one is something that was taught in Form 1. Ikitu mlifanya Form 1. Do you remember doing this one in Form 1? Did you do something like this? Indicator color in acid, color in... It is a very common question in Form 1 class. Chemistry. In normal tested a lot. So now, I don't want to talk about the choices of indicators. I don't want to talk. Let me wrap this one first so that we proceed. If I'm moving too fast, if you cannot hear what I'm saying, you raise it. Yeah? Unasema nikiongea mbio sana mnaniambia. Now, when you are using choice of indicators, I don't have a problem because mostly we don't use a strong acid, we don't use a strong alkali, we don't use a strong acid, we don't use a weak base because now sisi tumezoea tu kutumia nini? Methyl orange. We use methyl orange and the phenolphthalein. So that one is okay. Now, we have three types of titration. We have the direct titration, back titration, and redox titration. I don't know. Yenye tulifanya last year, I cannot remember very well. I don't know, Maura, was it direct or the redox? What were we calculating something? I cannot remember very well. Maybe you can tell us something. I think I remember for the other year, ilikuwa titration bill. Was it no, was it 2025 or 2024? So 2024, the titrations were two. It was combining the direct and titration, and then now you have to go for the back. From the word back to Evo. Evo, back. You start from back. So this is a type of titration. So let us just proceed, and then as we recall, I don't know if they sent the practicals. Yeah, KCSE. But all practicals are the same. I don't even believe in people saying that they can predict a practical. In fact, if you can remember how to handle something, then you're okay. So this is a type of titration that involves the addition of a standard solution to a fixed volume of an analyte. Of course, analyte means something that is being analyzed, or the vice versa. So it can go either way. Now we determine the sole direct titration is normally very easy. You are determining the concentration. Ukipata concentration, remember the formula for calculating the RAM, so you can get for that one. You can get the percentage composition. So the ones are very easy. Now, I'm not going to do this one now. I want to change now the book and the long one how we do this thing. Especially filling that table. Because this one does not actually give us the feeling. So that you see how we fill the table. I don't know. Let me open that book. So I am very sorry for moving EV, but I wanted us to application. So I said this thing is normally very good actually. When you're dealing with human and easy, it is very good. Actually, kama umeelewa na uende ufanyie examples huko. Ukitoka this book, ukiwa umeshasoma KLB na ukuje ufanyie uone venye wanafanya kwa Longhorn, it is a very interesting. So acid bases apparatus used when you're dealing with volumetric analysis. You see this one is saying titration directly, yeah? Because actually volumetric analysis is titration. So there is no problem. Now, the reason why I'm coming to this one is for this one. So the apparatus, you have the balance, which I will give you the balance because sometimes mnaambiwa umepewa 2 grams juu nimesha kupimia. But when if you are in the higher levels, unajipimia the 2 grams. So we don't advocate for giving students. So we have the measuring cylinder. These are the apparatus that we commonly use in volumetric analysis. That is in titration mostly. Measuring the volumetric flux to make solution. of known concentration, because I said these are normally used to measure accurate volumes. You have the pipette in it to deliver volumes to the conical flask. You remember unasakra mudomo using the pipette. Alafu burette, you release small amounts of solution into the conical flask zenye sasa umeshaweka mpaka indicator. Beaker, carry and pour solutions. Funnel is very important. Now there's something about using the funnel. I just want to mention it now before we go. Unaona funnel ukishaweka, funnel is normally used for delivery. Now let me ask you first, for those who have sat for the exam, do you normally use the funnel ukiweka liquid kwa burette ama mnawekanga aje? I need this one to be answered. It's not a rhetorical question. Mnatumia funnel to deliver the liquid to the burette. Sana sana huko juu.
Funnel.
Now, do you know what? Sorry, is it the network or it is my earphone? Because I was trying to connect my Bluetooth, it was not working. So, when you're using the funnel, can you hear me very well? The reason why I'm saying that is because ya Mwaura imekatika katika twice. I thought it was a network problem. Yangu inakatika
Yes,
katika
teacher, you
kweli.
are audible. Unasikika Mwaura ndio yake inakatika.
Oh, yeah, nimesikia Mwaura almost twice, so I was worried that, could it be the same? But yako Monica, it is okay. Now,
Yeah.
ukitumia funnel, let me just advise you, ukishaweka funnel, ukitumia funnel na imefika 0, unang'oa hiyo funnel. So funnel. Juu funnel, unajua funnel inabaki na some droplets, Now, hiyo droplets
Yeah.
inaweza affect the volume that you will use or the volume that you will measure. So itaenda iharibu maybe you lose marks for what we call accuracy. Because there is
Kwa
what
hivyo
we call the
ikifika 0 mtu anafaa tu immediately.
unatoa tu immediately. Juu umeshapima zile ulikuwa unataka. Uweke kando.
Yeah.
Ukikuja kurudia unarudia tena, unarudisha funnel. I think that one most people normally forget that one. So hiyo inaharibu accuracy and then you lose 1 mark. You know there is 1 mark. I'll explain that one nikiwa kwa I think where we are headed. So we have the white tile or paper. There's no problem. I don't know, mnapewanga hizi kweli? The white tile or a paper. This one is only to help you in the observation. You white is easily seen. Although yellow is very bright, we cannot give out yellow. We give out white. And then dropper, that is to add the indicator. Now, so when you're handling, so you issue this one. If you have a question, you tell me.
Yeah, you have said the function ya white paper. I don't know what paper hiyo ni nini.
Unapewa white paper, ile photocopy paper. Ile ya photocopy ama tile ile ya what do you call ya bafu? Ya bafu. Unaona tile kama ya bafu ile ndogo. Sasa what you do, let me show you what you do with that so this one is how you use that pipette filler. Nilisema tumie mdomo. And then you transfer it to the conical flask. Iko na graduated mark hapa. So and then you transfer it to the conical flask. Now, ukisha transfer to the conical flask, this is what you are doing. Now, this one now is what I was telling you, but we are not explained for all two in the KLB. Wrong viewing ni usomee hapa juu. So you're supposed to kusomea wapi? Hapa chini. From the meniscus. That one. So the pipette and then you transfer the conical flask. Ukisomea juu, you'll get a wrong one. Unaweza kuwa unatumia 23 or 24 centimeters cube. Will affect your solution. It affects your concentration. Now, let me tell you where the tile goes. So, ukishaweka hivyo umesha transfer this one to the conical flask. That way, you use the dropper, you add indicators. Indicator, you add 2 to 3 drops. Now, mimi nimesema a standard value, ongeza 3. It doesn't matter by the way, hata ukiongeza 10 drops. it will still change color because it is just an indicator to show you. Ikisha kuwa what do you call when it is neutral now, that means the acid and the base imekuwa neutralized, there is no problem. So inakuwa nini? But it is advisable to add, wacha to add 3 drops uniformly. Weka 3 drops in everything that we are doing in the lab. Wacha niseme hivi, kila kitu yenye tunafanya lab, hata kama wamesema add sodium hydroxide, so let us add few drops equal 3 or a few amount. Add few, wanasemanga add few drops and then you add excess. So few drops equal 3. Uko sawa? And then excess umwagie yote yenye imebaki kwa hiyo dropper. Si mnajazanga dropper mkichota. So una add 1 2 3, that is few drops. Wakisema excess, pinya yote iende ndani. Then you see the observation. Aya. That one is, I normally advise students to do that so that they don't get confused. Because now somebody will ask you, how do I measure few drops? So tumesema few iko ngapi? 3. That is the measurement. So after adding the indicator, there will be color change. Now filling the burette, ndio hii sasa ile maneno yenye nilikuwa nasema. Now this one is the burette. So unaweka the filter, the funnel juu alafu unamwagia. So as it continue, this is the correct method. Ukishamaliza, you remove that thing. Nimesema you remove, So and nimesema hapa juu ni 0. Alafu hapa chini ni 50. So it is very easy. You read from 0, 1, 2, 3. Pali nasimamia actually is the correct reading. So hakuna shida. Now, there is no problem. Mimi sina shida. So you have added the conical flask, a few drops. Alafu sasa you run against the burette. So unaweka chini. Now ndio hii white tile. Monica. White tile
Yeah.
ni kukusaidia uone solution ikichange. Unaona time ingine labda umeenda shule yenye hawana meza, wanatumia flow kufanya hii practice.
Yes.
So flow kala unaweza pata flow hata wameweka vitu ingine, labda imefade ni black ama ni, so kuona kala inakuwa shida. So it is very visible wakiweka kitu chini ya white, so immediately it changes. Hii burette iko na tap hapa, unaona hii tap, unafunga tap, ikichange tu unafunga tap. And then there's something I almost forgot ukitumia burette. Burette usifungulie yote. Unajua watu wanaenda kufungulia yote kama maji ya tap ile, unafungua yote ijae haraka ati badilika haraka. You don't do that. Unafungulia drops polepole as you stir. Una swirl, let me say you swirl because you don't stir. Unafanyia hivi kama venye unataka ukiweka sukari kwa chai na unataka iishe chini, so hivyo that is swirling, you swirl. But now as you watch, now it is very important for you to be very keen when you are using when you are doing this titration process. So usiangalie mtu hata hiyo time, it is only a few minutes, maybe 1 or 2 and you are done. So hiyo 2 minutes inataka ile you be very keen. Now you love your answer. This one is actually the titration process. You fill in first and you transfer to the conical flask. You add 2 to 3 drops. That the nutrient to ongeza the 3 drops. There will be color change, and then you run until there is another color change. There is an example we will see, because there is something I want us to know. Now this one, record the volume of the titration results. Record the volume of the titration. Now this one is normally 4 marks. It is normally 4 marks. And these ones, I normally say it is normally 3 marks. It is 3 marks, especially for you in the 3 marks. We are supposed to score 5 marks free. Kujaza hii table ni 4 na kuna average volume. So I'll explain maneno average volume later, but let us just fill the table first. Now, when you are filling the table, it is very easy. They have already simplified for you. So initial volume is 0.0. 0.0 uko juu pali lisimamia ukianza experiment, pali hiyo liquid iko kwa burette ni 0 point, and they have said it is final burette reading. not the pipette reading, inakwanga tu final burette reading. So ni zero, initial ni zero, yenye inaingia katikati yote ni initial 0.0. Now there is a rule for filling this table. Lazima it has an accuracy. The burette actually, just like the meter rule, has an accuracy of 0.0, 0.1, 0.5. Iko na decimal moja. It has an accuracy of 0.1. So it is either 0.0, 0.1, 0.2, 0.3, 0.5, hivyo 0.9 mpaka 1. Yeah? So it has an accuracy of 0.0. Na sijui hata watanirecord aje hii, ndo watu wasisahau hii. I'm going to repeat this one twice. Now, when you are filling this table, make sure, or it is a must, that your values have a decimal of 1 or 2. Lakini for the sake of this today, or for the sake of your exam, we are using one decimal place. I don't normally advise students to use 1 or 2 because they will atajaza hapa na 1, ajaza hapa na 2. So we use 1 decimal place. Yenye unasoma zote zenye unasoma zinaandikwa juu hizi. Zote zenye unasoma unaandika in the upper side. That is after doing the process, doing the titration. Before starting the titration, zote zinaingia the second lane. Zote zinaingia the second lane. And then it is very easy now. Ukipata the final and the initial, you just minus. Ya juu na ya chini. So it is very easy. You don't get a negative. Now, there's a student of mine who got a negative. By the way, usually, I don't know, students do not read this thing. Final and the initial. They want, yani watoto wanataka vitu ikuwe ngumu. I don't know if you have the same problem. Yeah, there was I think it was Monica who said, mwalimu si nimefanya ikakuwa rahisi. Yeah, inapaswa kuwa hivyo. It should be very easy. Sisi hatutaki muumie. Shida sasa wewe umeona nimekupea 4 marks, unasema what? Hii marks ni mingi sana na imekuwa rahisi. Wacha nifanye ikuwe ngumu. That's actually what students do. So imefanya kuwa rahisi, so you minus ya juu minus z, that is how you get the volume. Now, we'll talk about calculating the average titer. Now, something
Sir,
about yes.
before you proceed, can I ask a question over there?
Please do. Yeah, it is okay.
For your recording, we have the first, the second, and the third. Last nilifanya practical ni kitambo sana. Sasa I was asking the first reading, tunafaa tuwe na first reading, the second and the third.
Yes.
Nauliza yeah, lazima tunafaa tuwe na first reading, the second and the hii ya tatu, si ndio?
Yes. It
Sasa
is a
the first
must.
one Sasa ya kwanza sasa hiyo ya kwanza nauliza hapo mi hata nasikia kuchanganyikiwa juu I don't know ni vile hiyo practical sijaifanya ama niaje juu, yani where do you get the first reading, the second and the third? That is my question.
Okay, no problem. I think I'll answer your question. Yeah, it's a good question and it is very relevant. Came here before niendelee. Now, let me go back kidogo. Let me just explain that one. Let me answer a question. Unaona hivi sasa ukishajaza burette. Burette, before you run, the burette is full. Now, before you run, the first reading ni hiyo sasa, initial reading ni before uanze, si ndio? Ni 0.0.
Yes.
Ukisha run, after running this one now, you see now there is a color change. For example, we have purple. Ukirun, mpaka ichange ikuwe colorless. Or kuwa yellow na ichange ikuwe orange, unafunga. That one is the final reading. hiyo ni final reading. Uko sawa?
Mm. Mm.
Alafu sasa you minus that one, so umemaliza titration number 1.
Okay.
Yes. After that you repeat the process again. That means you pour hii yenye ilikuwa hapa, una pipette something another one. You pour this one and you check the question. Some questions will say store it for the next process. So unamwaga hii and then now you start the process again. You pipette, una suck na mdomo, una transfer, you add again the indicator, alafu urudi sasa urun again sasa the second time. Yeah, you repeat the process, the same process, but it is easier when you are doing a question, which I know there is a question that you are going to do hapo chini. Yes. So don't be worried. I'm going to explain very well tukiwa kwa swali. We'll do one question but very important.
Okay.
Now that one question, the reason why I wanted to stay more on filling the table is because it is touching on direct titration, redox, and the back. So sitarudia tena huko, or nobody else is supposed to repeat the filling of the table again. But we will see that one. So another rule that you're supposed to have before I give you the marks hapo kwa this table, weka realistic values. So nimesema ya kwanza ni decimal place. Tumesema tunatumia decimal moja. Use one decimal place. For example, 21.5, that is 1. 0.0, that is 1 decimal place. Yeah? Iko sawa? So we use 1 decimal place. Usiweke mingi, usiweke mbili. Let us use 1. All of us tutumie 1. That is rule number 1. Rule number 2, andika realistic values. First of all, burette yenyewe, 50 centimeters cube. Tutumesema ni 50. Now, realistic values, uwezi niandikia 70, 80 na haifiki hata 100. Unapata mtu ameandika 200 centimeters cube final reading na liquid ulipewa ni 100, so ulitoa wapi 100 ingine? So fill in realistic values. For example, most of the values actually does not go beyond 35. That is actually in all practicals. I don't know if you know that, but most of the values is 30 and below. It doesn't go beyond 35. Of course, we have factors affecting the rates of reaction. That is why I'm adding plus or minus 5 from 30. And I'm going the upper end of 35. So all titration, make sure that you have, it is making sense. Don't write 120, 2000. Mtu anaandika 2000 na amepewa volume ya ya kuweka kwa brain ni 100 centimeters. So ulitoa wapi 900 zingine? So that one is is another. Write realistic values. Another thing that you're supposed to write or that you're supposed to know. Now, kwa hiyo ukijaza table, I normally now kujaza doing the titration actually is normally a cumbersome process and normally takes a lot of time. If you're not keen, utamaliza timing. So I normally advise students to do 2 titration na wa choose moja yenye ni ndogo kwa the first 2 na ikuwe titration number 3. That is if time does not allow. But if time inatosha, you umalize. Now, rule number 3, you must have 2 values. 2 values in the volume used should be a difference of plus or minus 0.2. That means, I don't know if you know the meaning of plus or minus 0.2. Plus or minus 0.2. For example, let me just use this example. Hii wamepata 21.2 na hii ni 21.1. What is the difference between 21.2 and 21.1? No, you answer that one. Let us check if we na nijue kama tuko pamoja bado.
Sure. Your question is?
What is the difference between 21.2 and 21.1?
Yeah, 0.1.
0.1. Does it fall under this category of plus or minus 0.2? That means you have two values zenye ukiminus haipiti
Yes.
0.2. That is actually what is this one is saying. So kwa hii
Okay.
either 1, 2 zikuwe hivyo ama 2 and 3 zikuwe ukiminus inaleta 0.2. That is why I'm saying kama unaona umefanya number 3 yako ya kwanza ikakuwa 21.5 for example, ya pili ikakuwa 30.4, alafu ya tatu ukapata 28.3. Hapa yako hakuna yenye imekaribiana, si ndio? Hakuna yenye ni plus or minus 0.2, not plus or minus 2, plus or minus 0.2. So what you do, that is why I'm saying I normally advise students that ukifanya zako na zote zimekataa kuingiana and you are already late, you have wasted a lot of time doing this citation na haitoi, what you do, the most accurate, bora ulifanya hii na hii correctly na hiyo ingine ikachange differently, you choose the lower one yenye ni ndogo, which is smaller one between the two, sini 21.
Yes.
So unaandika hata 21.5 or you write now plus or minus 2, unaweza kuwa 21.3 ama 21.7, so that it can help you somewhere else. It will help you somewhere else. I don't know if you have understood what the 3 rules that I've mentioned. So rule number 1, we use a decimal place 1. Rule number 2, write realistic values. Values in a make sense. Don't bring very large values that does not make sense. And then rule number 3, all your answers, at least 2 of them, if not all of them, that is, should have a difference of plus or minus 0.2. Now so that it helps you, itakusaidia pahali. Mumeelewa hiyo table? Because table actually, ukijaza table hivi, you already have 3 marks. Sure, 3 marks. Umepata 3 marks already. Now, the 2024 exam ilikuwa na table mbili. I cannot remember ya 2020. I don't know why, but I remember ya 2024 very well. Ilikuwa na table mbili. So, ukiingia exam room hivi, hata bila anything, hujafanya kitu, mtu alikuwa na 6 marks. Haujafanya kitu, umepata 6 marks. And actually 6 marks, I don't think people know what 6 marks can do to them. 6 marks is a lot of marks. You have not done anything, umepata 6 marks, which is a lot. Now, there is another 1 mark upper, which is the average volume. The only mistake they normally do when they ask the average volume, which is actually question 1, is they don't follow the rules now. So when you're doing the average volume or the average titer used, the average volume of the acid used, you only add those numbers that are plus. Sasa ile rule yenye ilikuwa nasema plus or minus 0.2 inakusaidia kufanya nini? Kupata average. So inakusaidia hapa sasa. So you only add those ones. That is why you are seeing we ameadd 21.2 na 21.1, lakini amewacha gani? The difference is large and you want very accurate things. So you only add the ones that are plus or minus 0.2 and then you get this one now is another mark. So ukiongeza 3 plus 1 inakuwa 4. So you're supposed to score 4. Now there is a mark I left out hapa, which is 1 mark. And this one is normally for accuracy. If you're accurate, and the accuracy normally is given by the teacher. I don't know. Let me just ask for, I think Maura is the person who did the exam the other year. Did you have somebody who did an exam, who did a practical yenye mulifanya na akasubmit some values to, so that it can be used to mark your values? Do you have those people? I don't know if she's still in. but there is what we call the school value. The school value is normally done by the teacher, and then it is submitted with your so that it can be used to mark yours. So if for example, the answer that you got, for example, is this 21.2, 21.1, and 21.5, and then the teacher got 28.1. Now you lose the accuracy mark. So they assume the teacher is correct. You are not correct because you don't know. That's what they're assuming. Which is quite unfair, I might say. But nobody cares about fairness because they're assuming that the teacher is correct. Yeah. So you lose the mark for accuracy. Now, but if your answer is 21, na mwalimu amepata 20.5, for example, you get the accuracy mark. Now, the accuracy, they add a value. You either add, so for accuracy, it is plus or minus, I think almost 1.5. And it is a bigger value, plus or minus 2. Kwa sasa yetu, that is for accuracy. It is not for calculating what? Now, the reason I don't normally test students is because of plus or minus 2, plus or minus 0.2. Inaletanga confusion. But anyway.
Yeah.
Yes?
Hapo kwa average volume tumetumia 21.2 na 21.1 but we
Yes.
didn't use 21.5. Mbona? And there are 3. Ama because the first one is initial.
Sorry? Because the first one is?
Initial ama ni kwa sababu gani? Kwa nini
No.
hatujatumia
You
21.5?
unakumbuka nikisema there is a rule ya plus or minus 0.2. You remember that one? Now, when you minus 21, na 21, when you minus the 2, inaleta 0.21.5 minus 21. Inaleta 0 point.
Sasa nifanye tena.
21.5 minus 21.2.
0.3. Hii inaleta
Now,
0.3.
na nikasema huko juu, make sure that you have values that is plus or minus 0.2. Unakumbuka? Na nikasema itatusaidia pahali. Now, the only one that we allow you to do an average is those ones that have a difference of plus or minus 0.2. So when you, yes, so ikipita 0.2 plus or minus, you leave it out. You don't factor in as the one that is used for calculating what? The average type. Imepita hiyo the boundary that you're given for accuracy. Yes. So unawacha. That is why nilikuwa nasema when you're filling this table, make sure that you have 2 values that have a difference of plus or minus 0.2. In fact, ukipata hivi 21.1 na 21.1, this one you use these ones alone. So unawacha yenye imepita ingine. That is why we have 3 and not 2.
Okay.
Yes.
So.
Yes. So that one is very important, and that one has been bringing confusion. And I know people do the same mistake. Now, so that is how you do. I want us to do something. I want us to see something else. Example of a practical titration that is done. So you are provided. So this one is what this one is actually how the question will be placed there. To solve the two water, you are provided with solution A, which was made by dissolving 5.3 grams. Of course, in 1 liter. If you can see, it is per dm cubed of sodium carbonate. And then they have given you the name. And they have given you that. The good thing about them, they normally give you the chemical formula. Solution B, which is hydrochloric acid in 1 dm cubed solution. You are required to calculate the molarity of sodium carbonate. Standardize solution B with solution A. Yeah. Then you have been given those things. Now, the procedure, they give you the procedure. The last time I saw a question asking for you to fill the procedure, imekuwa kitambo sana. Pray that you are not asked to fill the procedure. But the procedure is very easy. So, number 1, Fill the burette with dilute acid provided. So unajaza burette the way we said, unaweka burette na unaweka funnel na unamwagia. Ikijaa zero, ikifika kwa zero using the meniscus, unatoa. You remove the filter funnel, the funnel. Now pipette 25 centimeters cube of solution A and transfer it into a conical flask. So una pipette, nilisema pipetting you can suck using your mouth. And that is why I was saying, if you had a practical station, literally, ingekuwa tamu sana. Because we'll be doing what we are saying now. So fill the burette to the fill, ukiona. And then even I would have given some of you to fill first before we continue. And then you pipette 25 centimeters cube of solution A and transfer it into the conical flask. Add 2 to 3 drops of methyl orange. Yeah, so you add 2 to 3 drops. Now, unaona color change. So you, of course, they will not tell you to observe the color. There will be color change. Now, the question is not actually very fair for you. Inasema titrate until you get to the end point. Now, the end point, they are asking, how will you tell that the end point has been reached? So there will be a color change. Yeah. So, ukifika end, it will change from yellow to maybe orange. Others will change from purple to colorless, depending on that, but we are using the methyl orange. So titrate until you see there is a color change to orange, utaambiwa. Yeah? Or they'll just tell you there is a color change. Now, we continue. I hope everybody can see this one. Huh? I hope
Yes,
everybody can see.
that
Yeah.
yeah. Mm.
Yeah. So you continue. Repeat the titration. Do you, Sasa Monica, you answer to that question? Repeat the titration 2 to 3 times to get consistent values. So the only reason we repeat is because we are human beings, and that is why I was saying human beings make errors. So we only do 3 times for consistency.
Mm.
There is no way the only thing that can get actual results is what you call the AI. The computer actually can give you perfect results. When you run a simulation, we normally call it simulation online. Kama ina change at 20, itakupea 20 20 20 20. But human beings, because you're human being,
Yes.
kutakuwa na hiyo error ya kufunga, unaweza chelewa kufunga hivyo. So inakuwa, and then you record your values in that one. Yes. So so ukiweka moja, so what they are saying here is, now number 1, kujaza titration number 1, that is E, burette read 1, titration 1, unafanya procedure 1 2 3, iko sawa? Alafu you pour that one out, you go to, you repeat titration 2 again. So titration 2 unarudi tena kwa procedure 1 2 and 3, na unamwaga tena, alafu tena urudie tena procedure 1 2 3, hivyo hivyo mara 3, but you add different, unaweka different conical flask. Kitambo walikuwa wanapeana conical flask 3. That means it was the whole process. These days they only say they recommend to give out 2, so that you pour 1 and then you remain with 1. So na ukimaliza, nilisema kama time imekupata na umepata values 2 already, you don't have to do the third one. You just choose the lowest kwa ile 2 yenye umepata. Kama ulipata 20.1 na 30.1, unachukua 20.1 na ujaze kwa 3. That is the better, the most accurate one is the smaller one. Now, find the volume of the acid that reacted, that is calculate the volume of the titer. Standardized solution B using A, find the molarity of the carbon. Those ones are very simple things that we did previously. But I'll give you now, they have given us a specimen result. Yani wanasema kama tungefanya, jua tu kufanya sisi, sio? Tukifanya, we could get something like this. That is a specimen result. And everybody normally, I don't know why students normally try to copy. The practical, Actually practical, kila mtu anaweza pata kila kitu as long as you don't copy, because I expect that because you're human beings. Kama wewe peke yako huwezi pata the same answers. For example, huwezi pata 22.5, 22.5, 22.5. Now, and you are 13 in a class. So it is not possible for 13 people to get the same answer. Is it possible? It is not possible. It is not possible. Because kila mtu reaction, of course, the reaction rate, of course, I don't know if you normally, I'm a documentary person. So if you watch the fastest animals to move, to react to something, hata sisi hatuapia, I don't think we appear in the first 20. We have kina cats, kina inzi, and the rest. Those ones are very fast. They react very fast. You have in seconds. Human beings, no, we don't even appear there. If the snake is there, that is what I'm saying. So it is not possible for Monica. You have 22.5, 21.9, and 21.8. And then naenda kumaki ya Mwaura akona 22.5, 21.9, 21.8. It is not. It is not possible. It is not possible. It never happens. So and those are some. It is very easy to know irregularity in practical. But lakini nyinyi, I don't have a problem venye nyinyi mnafinywa. I don't think there will be any irregularity. Whatever the case, just do your own work in
Yeah.
practice. Yes.
Yes, but in case kama unahitaji msaada like hizo vitu maybe
Sorry?
ukicontact mwenye ako hapo, nasema
Eh,
in case kama unahitaji msaada wa kufunga hizo vitu, ukicontact mwenye ako hapo, itakuwa ni kama kuulizia majibu. Is it a penalty
No,
ama?
in fact, that is their work. They're supposed to help you to connect those things, just in case you don't know.
No.
Yeah, that is their work.
Mm.
You're supposed, time ingine wanasema wakuashie candle, not the candle, the Bunsen burners. That is our work hapo ndani, to just help you. I'm not supposed to give you answers. I can connect for you. Siwezi kuconnectia kila kitu though, labda nikufungie tu hiyo kitu usipasue, unaona? Yeah, but I know, the only
So
problem is, yes,
mostly walimu from different school, eh?
no, for students, I normally, for example, of course, if I have maybe, for example, I have 30 students, maybe 2 or 3 ndo hawajui kufunga hiyo kitu vizuri, juu wanaogopa watafinya, because now unafungia chuma glass, so somebody might think that are a password, which is not the case. So unafunga tu mpaka ishike, so somebody can help you. Now the only issue that I have with yours is, are the people who are helping you teachers of chemistry? I don't know. That is the only problem, because kama ni mtu anafunza English, they have never even used the burette ever since they left high school. So do they know how to use it? I don't think so. So instead of somebody telling you I don't know how to use it, they will just have to throw words on you. Yeah, so that is the only issue actually. But now the students will have a chemistry teacher and a lab technician. So we have a lab technician, we have a chemistry teacher, minus now the other people, or the invigilators or the supervisors. But there's no problem. I also for the best, although. Now, so you have the final grade reading, you write, and then the initial, of course, nimesema initial mara mingi. The first one, initial is 0. Now, I want you to see how it has been filled. 22.500, and then you minus, you get 22.5. So the initial, unaweza anzia final ya ile ingine ikuwe initial. Yeah, and then you get another final reading. So the final you minus again, you get 21.9. Now juu hii yenye imebaki haifiki 21, unajaza tena ikuwe nini? 00. So and then you get 21.8, 21.9. I want you to see how it has been filled. We have filled the table correctly. So kujaza hivyo tu yote umepata. This one is correct. So you score. So this one is okay. 1, 2, 3. And then there is one mark now that I'm supposed to give you for accuracy. That is, if I get a value that is plus or minus mine 2, nakupea hiyo 1 mark. Now I want you to see how this table has been filled. It is a specimen. Nilisema ukijaza table, you make sure that we have 2 values. Kwa hiyo yenye imekaribiana by 0 plus or minus 0.3, 0.2. Do you have those ones that are close to each other by 0.2? Let me rub this. Iko yenye imekaribiana by 0.2. That means the closeness haijapita 0.2. Do you have them?
Teacher, hiyo ya kwanza, hizo mbili za kwanza inaleta 0.6 difference.
So do we use that one? Does it qualify?
No.
No.
The other one ni 0.1 difference ya 0.1.
Yes. So unatumia
use the
gani na gani?
21.9 and 28.8.
Yes. Huh? 21.9 and
Yes, and
21.8, not 28.8.
yeah. Oh, 21.8, yes.
Yes. So unachagua hizi zenye, and this one now, yenye nimewapea ni specimen yenye imefanywa. Ukifanya we tumia zako zenye zimekaribiana, so that it can help you in answering this question now. Then we go now to this question, and it says calculate the average volume of solution B used. So the average volume, you add those ones. You know how to do the average. It is A1 plus A2 over the number of A's now. 1, 2, so 2.
Yes.
If it is A3, you divide by 3. If it is A5, you divide by 5. How you do? Now, write an equation for the reaction. So that is why you remember nikisema when you're doing the tukiwa huko juu nilisema you are supposed to know how to write equations. You see now they can ask you to write the equations. And they have given you only they have not given you the product. They have only given you reactant. So you should not forget those ones. And then you have the mole ratio. You don't have to get the mole ratio actually when you write the equations. Now I will not discuss a lot of these ones. Now you can calculate the moles because you have been given 5 grams. You have been given 5.3 grams per dm cube. And you have been given the individual masses. This one, where is it? Yeah, you see they've given you sodium, 23, oxygen. So you can calculate the RFM. And then you have, so that you can get the molarity using the number of moles is equal to mass over RFM. So it is very important to, that is what, this question is very interesting. The only problem is we cannot calculate directly. Now let us see. So sodium carbonate is written as, so it is 223 plus 12 plus 16 tatu inakuwa 106. Sindio? And then they have said we are dissolving 5.3 grams in 1 liter. So we can actually get the number of moles. Sindio? Which is saying, using this. That is why I was saying this book is very good kama umeshaelewa. Lakini kama hujaelewa, so we have, let me just give you this one, number of moles. But this one is a very good practical. Tunaona tungekuwa tunafanya practice ingekuwa mzuri, ingekuwa easy ya kuelewa. It is easy to understand when I'm showing you directly. Nakwambia fanya hivi, hata wewe unafanya hivyo. I don't know if you are seeing. So number of moles is equal to, it was mass over the RFM. Now we have calculated the RFM already. Ndio hii 106. Now sisi tukaambiwa ilidisolviwa 5.3 grams. So that is 5.3. That is where we are getting this one. Sorry. Yeah. 5. And then you get 0.01 mole. So the molarity of solution A, that is the one that is 0.01. M, capital M. See, this one was dissolved in 1 liter. They're saying they're dissolving 5.3 grams in per dm cubed. See, it was written per dm cubed. Let me just write for you. It becomes per dm cubed. Now, uko, when you were starting this this topic, there's a place I told you 1 liter is equal to 1,000. So we just continue reminding ourselves as we continue 1,000 centimeters cubed, which is equivalent to 1 dm cubed. So ukiona dm cubed pahali ujue ni 1 liter na ujue ni 1,000 centimeters cubed. So you should not be worried that maybe ukuona hiyo. So it is very important to remember those things. So you get the moles, but now that one is the molarity. Remember the volume that reacted. It is not actually 1,000. Did we use 1,000? We did not use 1,000. We use a smaller value, a smaller volume of around 25. So this one is in 1,000. What about 25 centimeters? So you get a very smaller one. You see? Now we can say 1,000 mole of solution contains 0.05 mole. Lakini yenye tumetumia yenye tumepipette ni 25. So how you calculate? You do that. Now, the reason why we write the equation is because of this one, so that you have the mole ratio. So hapa tuko na mole ratio ya sodium carbonate to HCl is 1 to 2. I know I'm moving very fast, but I want to do it very slowly. Nataka muniambie kwanza kama umeelewa. Is it making sense? Before
Yes,
I
teacher.
it is making sense, eh? So tumeshapata moles zina react hapa kwa 25 centimeters cube, lakini kwa equation tuliandika tukapata mole ratio ya sodium carbonate to HCl ni ona, nataka muone hiyo equation. Sodium carbonate ni ngapi hapa? Si ni moja, one is supposed to
Yes.
be, alafu HCl ni ngapi? 2. So the
Really.
reason we wrote the equation is so that it can help us now calculate the moles of HCl. Juu hatujui, tunajua ya ile ingine juu tulipewa the value, tulipewa value yake juu tulipewa 5.3 grams. Hii ingine hatukuambiwa ni nini. So you do the mole ratio, that is the moles in 1,000 centimeters, and then now you calculate the volume that you were calculating, which was 21.85 volume of the acid used. You can calculate so that you get the molarity. You kama mnaelewa hii kitu. Now I want to give you something so that you see if you can do it. I just give you a few minutes, maybe 1 or 2, because I'm trying to think if we are starting something, another question we might not complete. I know people are very tired. I am feeling that people are very tired today. I don't know. It is Monday, so I understand. I don't know what Monday comes with. But I think I'm hoping that you'll have but I don't know. As you continue, I'm hoping that you have a practical for this one. So example 2, I think people can really try this one. There is nothing that you're supposed to do. I'm supposed to give you values. I don't know. I want to take this one, a picture. So nataka kupiga picha hii, alafu I share with you. I don't know if it is okay.
Teacher,
And then
tunakusikia.
I give
Share.
you, no, I'll give you the specimen results so that you can try and calculate. Sindio? Can I share in the group? Yeah, let me just put it in a group so that I think if so that we can do it on Wednesday. I'll prefer to kusema ukweli, I don't know. I have a feeling that I prefer to do this question on Wednesday morning when people are better off. What do you
When
think?
is the morning?
Yes,
Yeah, itakuwa teacher.
every Wednesday morning.
Yeah, but you can send that. You can send so that tunaweza iangalia manual.
Yeah. I'm sending it over. I've sent it to the group. So the question is cut into 2, but it is a continuation. So I don't know if the question is calculate you're required to determine. Calculate the. I'll give you the question. Okay, I think the question is okay. So let me just so I told you this book is very good. No, the book is very good. So let me, especially in the examples, let me just share this one. So nimetuma one of the questions, the other part. So I'm sending the second part of it. So this one is a sample that has been done. But maybe I'm not as happy as such giving something that has answers, because now I wanted to know if people have understood my the rules that are used in following. So this question is actually is saying you are provided with, so these ones have given you the molarity of HCl actually. So it is easy. It is easy. Indicator is methyl orange. Titration apparatus, you are required to determine the concentration of solution, and then they have given you. So we are not dealing with hiyo maneno ya you pipette 25 and then you transfer to this hivyo, and then you have the specimen result. Now I will repeat again this one. When you are filling this table for the last time, let me just repeat it for the last time. When you're filling this table, when you're filling the table, tafadhali weka decimal moja, usiandike 22 juu obviously utapata 22 huko, unaweza pata 22 flat. So it is wrong to say 22, but it is correct to say 22.0. So that one is very important. 0.0 usiandike 0 peke yake, 0.0, so that it can show the accuracy. 22. So
Teacher,
yes.
so namaanisha hata tukipata yani a whole number we should put a decimal point.
Good, you have answered that
Is
question.
that
Yes, that is what I'm saying. Ukipata hata 1, andika 1.0. Actually the point, now I don't know if you know this, but when you are told when you go to the bank and they tell you you have 1 million, and then the same bank somebody else tells you you have 1 million only, who is accurate?
I think the second one.
Yes. So it is the same thing. Ukiweka 0.0, that means there is no other value that can be added,
True, yes.
Yeah, because ukiwacha ikiwa open, I can say it is, ukisema 1 naweza kuja kusema oh ilikuwa 1.3 ama 1.2, unaona? So the decimal part is more accurate, and actually it is the accuracy of the burette. So the first question is to do the average titer. You said we had only those ones that are very close to each other. I want you to see this. This one is funny. I like this one. I think this one is funny. And actually the answer to this one, the calculating of the average is wrong. Hiyo yenye amefanya ni wrong.
Kwa nini teacher?
Now, what is the difference? Now, let me ask you, what is the difference between 22 and 21.9? What is the difference between 22 and 21.9?
0.1.
Okay, what is the difference between 22 and 21.8?
Mm, 0.2.
Now, what did we say huko juu? When the difference between all the values is 0.2, you add them.
Yes.
Yeah, so zote hapa, you can add 22.0 plus 21.9 plus 21.8, divide by ngapi? 3. Now, before I forget something. Now, if the answer is like this, let me give you this one before I forget. This one, I almost forgot this one, and najua itakuja iwasumbue. If you have 22.4, 22.2, and then you have 22.0. The reason why I think this one has reminded me that thing. Now, if you have three values like this, what is the difference between 1 and 2? Say it is 0.2.
0.2, yes.
Yeah, what is the difference between this and this?
0.2.
0.2. Now, what is the difference between this and this? This is 0.4.
0.4.
Now, ikiwa hivi, you choose two
Mm.
that are closer to each other. Unaweza amua kutumia hii, iko sawa? Ama uamue kutumia. Unawacha, yani huwezi tumia zote sasa juu difference zimekaribiana. Si ndio? So you choose the one only that is close by plus or minus 0.2. That is why I'm saying the answer to this one yenye wamefanya hii is wrong. Because if it was me ama wewe sasa, you're supposed to add what? Plus 20, 2, and then you divide, instead of 2, you divide by 3. So I want us to use that one.
Kwa hivyo teacher zikikaribiana zote unafaa utumie zote tatu.
Yes, kama imekaribiana by a difference of plus or minus 0.2 zote tatu. Unaona hiyo ingine yenye nimeleta, so unaona ingine iko mbali.
Na iko mbali ingine.
Yeah, ikiwa imepita 0.2, that is 0.3, 0.4, unatumia tu mbili zenye zimekaribiana sasa by plus or minus 0.2. Lakini zote zikiwa zinakaribiana, for example 22.1, 22.0, 22.2, una add zote. The difference is the same.
Yeah.
It is the same, and it is within that range of 0.2.
2, yes.
Yeah.
So
I don't know if I should continue, because the only problem with this topic is you cannot start a question if time is not enough. And we already have around, I don't know, 6 minutes, depending now. So you cannot start a question because of with Malaysia, and today is the night. So why don't you try that when we meet next? Now, if you are doing the practical, it is the end of this month. I think we only have the end of this month is 2 weeks too. So the last weekend is 2 weeks too. So these 2 weeks too, I think we still have some time. I wish when you're doing the practical now, because now you don't know a lot of things in the practicals. I think I'll advise that they give you one, especially for this one. Mfunzo venye hii inafanywa. Then it will be okay.
Yeah. Alafu teacher, hiyo exercise umetupatia tunafaa tujazie table.
Ati ni mujazie?
Umesema tujazie hiyo table?
Nimeshawajazia table. I want you to solve the question now.
Yeah. Ulikuwa unashangaa tujaza aje na naona
No, the table is now kujaza table. You remember nikisema it is I don't like these questions because they have wametujazia table, and of course we don't have any otherwise you are tuko live, like we cannot do a practical. So hii tumejaziwa tu, but I wanted people to know how to fill the table, but it would have been better if we could do the practical and fill it ourselves. Sawa sana. That's why I'm saying I don't know, because now you are supposed to be taught how to use the pipette, you're supposed to be taught how to use the burette, how to fill the burette, how to add the drops. Now it will be quite tough for the teacher will be handling the practicals if you do the quantitative, which is this one, and then you do again the qualitative. Qualitative ile sasa ya kutest cations and anions. So I don't know if I'll be around, but if I will be, we'll see. Okay, let us not just let us cross that bridge when we'll be there. Let us not talk about that. So you can try that question. And we'll do the same question on Wednesday if I'll be in. If Madam will not be in, you can just tell her to do the same, or you can do something else. Whenever I start redox, then I come and handle mine. There's no problem. because we have done with this one is direct titration, actually.
Yes.
Yeah. So unless there is a query, yes.
You said this one is a direct titration.
Yeah, this one is direct titration. It could be adding a little bit of back, but it is direct. Yeah, it could bring a little bit of back titration kidogo.
The other types of titration pia utafunza.
Yeah, it must be taught. We have the direct titration, we have the back the titration, and then we have the redox.
And teacher, by the way, why is it called back titration?
Back titration, we start from back. Actually, you are given the answer, and then you are told to answer why or to validate why that is your answer. That is the question. So unapewa answer huko, alafu naambiwa validate that it is true. And that is why it is called back titration. So redox titration is a reduction and oxidation process, especially when you're changing the ions. Huh? But that one, nobody will ever ask you why it is back titration, but they will give you a question that has back titration, and then you will see fire.
I just wanted to know kwa nini
back titration. No, it is back titration, which is good. It is good to want to know. It is good back titration because you're starting from back, huh? Coming now. Yes. Unless there's a question, unless there's a very burning question, I'm going to end it there for today.
But teacher,
yes.
I thought tutaendelea penye madam alikuwa amewachia, kwa hiyo chemist, I don't know, something like that. I thought ulikuwa utashika kidogo kidogo then we proceed.
I thought I touched on that one small. Even the example that we did, unaona example tulifanya huko juu.
Yes, but za madams zilikuwa zinakaa refu sana.
What I was doing is nilikuwa tu nawakumbusha. You know, madam told me I'm supposed to start on volumetric analysis. Yeah, so mimi nikasema I'll just remind ourselves maneno ya kuandika equations juu nilikuwa najua tunatumia hapa. You see, we have written one equation. Yeah. So that is why nilitaka kwanza tujikumbushe how you do the hiyo kidogo.
Yeah, but I think maybe utatuangalia one like yenye madam alikuwa anatufundisha, ndio tulifanya, alitusaidia, tulielewa, but we were expecting pia wewe maybe ugusie hapo then tuendelee, but for now I think time imeisha.
Yeah, the reason mbona tukuguzia, you remember there was a time tuliguzia yenye madam alifanya alafu tukatumia the whole lesson.
Yes.
Yeah, sasa leo nikasema nikakuwa mjanja juu mlikuwa wajanja siku ile mkanishinda. So nikasema leo acha niguze kidogo tu because I wanted something yenye itatu affect sana. So which was that one. But there's no problem. I'll touch on it again. We can even touch the same thing again. There's no problem. I'll still touch on it. I know I must touch on it because especially when we'll be dealing with the other the redox itatuleta huko bado. Redox because we write a lot of equations in the redox. Redox actually is reduction and oxidation titration, which is normally I don't know. I normally find that it is more confusing to students than the back titration. Back titration actually that question is back titration. So it is normally touching direct kidogo, alafu ikienda chini inakuwa back titration. Yeah. Yes. Unless there's a question, I don't know. We are only made with around 2 or 1 minute. So I'm going to stop the sharing. I know people are very tired now. So I can wish you a very beautiful night, a very beautiful week. For those who have not taken supper, have a very nice night. Thank you very much for attending this class. Bye-bye.
Nice.